Let's begin. Today is September 2nd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 3, 5, 9, 17, 19, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our middle digit, the square digit, and compares it to the number 3. So should the value of square be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B will look at our first digit, triangle digit, and will let us know whether its value is an even digit or an odd digit. Criteria card C will look at the 3-digit solution and will let us know how many of those digits are 3. Should there be no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card D again looks at our 3-digit solution, but this time will let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2? Maybe all 3 are even. Criteria card E will take triangle and square, add them together, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will look at the 3-digit solution from triangle, square to circle, and will let us know about its ordering. So should the values in the solution be in an ascending order, meaning that they're increasing, as in the example 135, or could they be in a descending order, where they are decreasing, as in the example 421, or could they have no order? So we look at the example 231. Notice that it goes from 2 to 3, it increases, but then it goes from 3 to 1, and then decreases. So it's that shift that is one way to define no order. Another example that we've seen in other puzzles is that if you have 2 consecutive digits that are of equal value, that also is an example of no order, because if you have, say for example, 225, if you go from 2 to 2, there is no either increase or decrease. So that lack of change is another way that you can define no order. And remember, the objective of today's puzzle is to find that one unique 3-digit code that abides by all the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I want to find out is a little bit about that first digit, the triangle digit. So let's go ahead and test criteria card B. Okay, so the Turing Machine approves of my choice for triangle. Notice I did choose an odd 3, and the Turing Machine agrees it should be an odd value. So let's go ahead and type that up in our notes for section B. And that is, of course, that triangle is an odd digit. And because it's odd, that means I can cross out all the evens. So let's cross out the 2 and the 4. So we've already established that we have at least one odd. We do have this criteria card that will let us know how many evens there are. So currently I do have 1 in my proposal. Let's see, what else? But I think what I'll do is, let me go ahead and test criteria card E. Okay, so again, the Turing Machine does approve. Notice that my first 2 values in my proposal, 3 and 1, add up to 4, which is less than 6. So that means the Turing Machine confirms that the sum of the first 2 digits is indeed less than 6. So let's go ahead and type that up in our notes in section E, and that is that triangle plus square should be less than 6. And since the sum has to be less than 6, I think we can actually cross out both 5s for triangle and square. The reason is that if you add 5 to even the smallest of values of 1, that's already 6 or greater. So that means that, yeah, it's not possible for either triangle or square to be 5. But I believe everything else is fair game. There are, 1 can be added to any square value and it'd be less. 3 can be added to some values of square and it'd be less. So, yeah, so I think we've crossed out all that we can. What else? Let's see, I did choose for square a value that's less than 3. So let's see. It would be interesting if we do get it wrong. Actually, that might be a good criteria card to test. Yeah, let's go ahead and test criteria card A. Okay, so again, the Turing machine does approve of my value that I chose for square, and that is 1. And of course, that tells us that square should be less than 3. So let's go ahead and type that up in our notes for section A. And that is that square should be less than 3. And since square should be less than 3, that means we can actually cross out some additional numbers, which are both 3 and 4 for square. So it can't be 3 and it can't be 4. And so that means that square has to be 1 or 2. And yeah, any combination of 1 and 2 with what we have for triangle, those will all give us sums that are less than 6. Okay, well, we've already completed our 3 Turing tests for round 1. So now we're going into the phase where we'll be discussing how to construct a good second round proposal. So obviously what we have not tested and confirmed are the number of 3s in our solution. We see that we have 2 opportunities for 3 in triangle and circle. We also did not test criteria card D. That lets us know how many evens there are in our solution. And of course, we didn't test the ordering criteria card F. And also notice, there's nothing in our 6 criteria cards that directly reference circle. So somehow circle will be forced into that value. It could be maybe the lone 3 or maybe a lone even. It's still up in the air, but that's something to observe. And of course, almost also the obvious. Could our solution actually be the initial proposal of 314? Is that possible? So somehow we also have to figure out, somehow we have to decide which of the triangle values and square values are valid, and then of course the circle. It could be that we have maybe 2 3s, right? And then a single even value. And so that would be, 3 2 3. Could that be? Because somehow we have to decide, right, which way to go. Although if we do have 2 3s and an even, does that somehow invalidate criteria card F, the ordering? So somehow we have to figure that into the decision. So what else could we do? Somehow, how do we figure out triangle and square? If there are no evens, perhaps. So let's see. I guess we can have some ascending, right? You could have 1, 2, and then you have 3, 4, 5 to pick for circle, and that would seem to be the only possibility for, well, there are 3 possibilities, right? 1, 2, and like I mentioned, 3, 4, 5. As far as descending, the only possibility would be 3, 2, 1, and then for no order, there are quite a few possibilities, and that would be 3, either 1 or 2, and then back to 3, 4, 5, 3, 4, or 5 for circle. So let's see. It would almost seem like if triangle were 3, besides 3, 2, 1, they all seem to be, to have no order. So it could be that they're going to be no order, but the number of 3s and the number of evens are going to basically figure in on our decision. So let's focus on that. So if we choose 3 for triangle, how could we? It could be that there may be 2 evens, in that we would choose, say, 3, 2, 4, and there's a single 3. So how do we choose between the 3 for triangle and the 3 for circle? Well, there are 2, let's see. Is there a way? So, because all of these, like I mentioned earlier, whether it's 1 or 3 for triangle or 1 or 2 for square, they all do already add up to less than 6. So that's covered. Yeah, I mean, it really comes down to C, D, and F. And how do we choose that? Three, 1. A single, how about maybe a single 3, a single even? Yeah, maybe that's what it's going to be. A single 3, a single even, and then perhaps maybe circle as 5. So it'd be something like 3, 2, 5. And of course, it would have to have no order. So what's it to prevent it from being 3, 1, 2, or 3, 1, 4? I guess that would be ambiguous. Eliminating square as 1 being a candidate and forcing us to choose square 2. Yeah, let's go with that. Let's say it's going to be 3, 2, 5. Okay, so let's go ahead and test how many 3s there should be. So let's go ahead and test criteria card C. Okay, wow, so it did not like a single 3. So we know there can't be 3 3s since square is already eliminated. It did not like there to be only a single 3. So either there are no 3s or 2 3s. Very interesting. Okay, so let's type that up in our notes. So we'll say there are either 2 or 3 3s. Okay, wow. So that doesn't really help us eliminate anything. We just know that we have either 2, I'm sorry, I apologize, not 2 or 3. Well, no 3s or 2 3s. Okay, so let me, yeah, I'm glad I caught that before we got too far. 2 or no 3s. Yeah, so we can't have 3 3s because square is already eliminated. It didn't like the fact that I have 1 in my proposal, so that just leaves us with either 2 or no 3s. So what would that look like if it was no 3s? Wow. Okay, well, let's go ahead and test now criteria card D, the number of evens. Okay, so it also does not like the fact that I have a single even. Okay, and I think very similarly, we can't have 3 evens because triangles are definitely odd. So, and it didn't like my case where I only had 1. So either I have 2 evens or no evens. Again, very interesting. So let's say there, there are either, I can't spell today, 2 or no evens. Okay, so let's see. So if I do have 2 evens, that would be square and circle. And we don't know if we can necessarily have duplicates. Duplicates are okay if we have no order. But yeah, how would you choose 2 and 4? Or between 2 2 or 2 4? I think those would have no order. So I'm kind of leaning towards maybe no evens, and so we have an all odd. And let's try criteria card F. Let's see how we do with that one. Okay, so at least that one we got right. There is no order. So let's go ahead and type that up, and we'll say that the solution has no order. Okay, so what does that say? Well, let's see. If I were to pick triangle, well, let's see. Let's take a look at the case where we have 2 3s. So it'd be 3 for triangle, 3 for circle, and that would mean no even, so it'd be 3 1 3. That's possible. Okay. Wow, this is quite a puzzle here. Let's see. So yeah, we're definitely gonna have to go to a 3rd round. And so let's see. Let's go ahead and start typing up some, possibilities. So we mentioned 3 1 3 as one candidate, and that's where we have 2 3s. So if we have 2 3s, and obviously we can't have 2 evens, so we'd have to pick the sort of the no even route. And so yeah, that's why 313 works. And that's the only possibility where we have 2 3s. So the alternative is we don't pick any 3s, and so that would force triangle to be a 1. And remember, we do want no order. Oh, this is interesting. Could we have a triple digit 111? I guess that's a possibility. Okay. But then we could have 115 as well, because again, that has no order. Or we could have 121. Well, we can't have 121 because it's either no evens or 2 evens. And so, yeah, I guess 122 could work, but not 124, because that's actually increasing. Okay, so let's see. So we have 111, we have 122, 121. Oh, did I skip 121? Oh, we can't do 121 because again, we need either 2 or no evens. Yeah, there's our 2 evens. Yeah, and it can't be 124. I think that might be it. There are either 2 3s or no 3s. So 313 is our only possibility for 2 3s. And then no 3s are the last 3 options. Let's see, what else? Did I miss anything? So yeah, that forces that to be a 1. And we need no order. So if we pick, yeah, we can't pick 2, or yeah, 1 2 2, 1 1 1, yeah, 115. Okay, so what makes these 4 solutions sort of unique? Are there any ambiguous solutions? I guess, yeah, it kind of comes down to retesting C and D, the number of evens. So I'm thinking that there probably are going to be 0 evens, because that may be, too obvious. So we're going to have to pick among the first 3, and potentially, let's see, what's the difference between 111 and 115? They both have no evens and no 3s. And they are, both no order. Yeah, I think we can eliminate 111 and 115 because they do seem to be ambiguous. They meet all of the criteria cards, assuming, again, no 3s and no evens. So yeah, so let me go ahead and cross out 111 and 115. Okay, now we're down to 2 3s or no 3s. So yes, I think we just have to pick one of those options, and based on the number of 3s. I guess we could also do it based on the number of evens. But let's go test. I'm going to choose 1, 2, 2 just because, I don't know, it just looks a little distinctive. And let's see what happens. So again, we're going to test the number of 3s. We test the number of 3s. Yeah, let's go ahead and test C. I don't think it really matters between C and D, but okay, so yes, we've confirmed that there are indeed no 3s. The Turing machine confirms that. So in our notes for C, let's cross out the either 2, and we'll just say there are no 3s. Okay, so just to confirm, because I do believe 1, 2, 2 is going to be our solution. Obviously, you know, the 2 previous ones that I did cross out also have no 3s, but I think we sort of concluded that they are ambiguous. They would meet all the criteria as well. Okay, so I do feel confident of 1, 2, 2. Too many things I think to cross out, so let's just type it up and we'll review. So it looks like 1, 2, 2 is the solution. We'll confirm in a bit. But yes, the middle digit is less than 3. The first digit is odd. Based on criteria card C that we confirmed, there should be no 3s. There aren't. At this point, we're deducing that you do have 2 evens, and there are. The sum of the first 2 is less than 6, and technically 1, 2, 2 has no order, as I just mentioned at the top, that if you have 2 consecutive digits that are equal, that also represents no order. Okay, well, let's go verify. And so we said 1, 2, 2. Let's see, did we get it? All right, yes, fantastic, it is. And let's see how we did versus a Turing machine. So this was an interesting puzzle. We went to 3 rounds, did a total 7 questions with 6 criteria cards. So let's see how we did. So we did great at the beginning. We got all 3 correct, A, B, E. And then in the second round, we did the remaining 3 and got the first 2 wrong. And then we had to retest C. So let's type that up. So A, B, E in the first round. So A, B, E were all correct. Second round, C, D were both incorrect, but we got F correct, and we retested C. So how do we do? Okay, fantastic. So we did beat it by 1 question. So it took the Turing machine 3 rounds, 8 questions in 3 rounds, and we did it in 7 questions in 3 rounds. So yeah, definitely a very good puzzle. A good twist. Obviously, when you get 3 checks, you almost, you know, have to almost fight the urge to keep it the same, because you know it's kind of rare that you're going to get exactly 314 as a solution. Not impossible, but you kind of have to question it, and so yeah, so good variety. What do you think? Do add your ideas and thoughts in the comments. Did you see any sort of inefficiency that we could have improved on? And if you like the video, please do give it a thumbs up so that more people can find this channel. And of course, hit subscribe to not miss out on any future videos. Well, until next time, have a great one.